Okay, I want to show you how to include regional flow in the YouTube model analysis. This is the model that was uploaded onto the website. So if I start with this, I want to put in regional flow in the X direction. So I'll do that by including two boundary conditions that will allow me to control the flow. I'll have an inlet boundary and an outlet boundary. And if I go to the inlet boundary, we'll have flow coming in here and here. And to have the flow come in the X direction, I will go velocity, pick velocity, and velocity field. And then I can select a suitable velocity. 10 to the minus 5 is 1 meter per day. So we'll try that. And then we need an outlet boundary, and we're flowing in this direction, so that's downstream, and that's also on the downstream side. We're just going to let it be a zero pressure. The pressure would actually increase like this, but if we think of this as kind of the differential pressure, then this will work just fine as a boundary condition. So we can run that now. So it runs pretty quickly. And what I think is a good idea is to check and just make sure that the velocity is going in the X direction. And so what we do is we've got a plot here. It's a slice plot with the XZ plane. So this is in the X direction. And if you just plot SPFU, then it's kind of hard to tell what's happening. And that's because the flow right in here, the velocity in that YouTube is pretty fast. So the scale just makes this all look blue. So it could be 0 or it could be a small value. But if I plot this as the log base 10 of the velocity, then I get a plot that looks like that. And you can see it's this green color, which is minus 5. So it's log base 10 of minus 5, that's 10 to the minus 5th, which is correct. So now we have this velocity going in the X direction, and we're going to compute the heat transfer. And so this is the temperature field, and what we can see here, starting to emerge, see this zone right here? This warm area in the downstream direction. That's the thermal plume that's formed by the groundwater as it flows in the X direction. So here's the model, the simulation, and if we get it just right, we can see that it's a little bit lighter blue there. Let's see. So I can see it on my display. I'm not sure how it's showing up on yours. A good way to get this to show up a little bit better is to use an isosurface plot. I have one already set up that I'll turn on here, and you can see this is the isosurface for temperature of 295. You can clearly see the effect of the groundwater flow moving in the X direction, and we can use this interactive feature to evaluate what the isosurface is for different temperature surfaces. Another thing we could do is use a player. This shows how the isosurface develops as a function of time, and we'll also use this to see how the groundwater flow moves the temperature field in the downstream direction.